Okay, welcome to day 5, relationships. We're doing the first part today, and part 2 will come up next. Today's going to be lots of stops and starts, so I'm going to get you to watch a little video and then go off, try something, come back, see how you did, back to a worksheet, and back to the video, and so forth. And then we're going to finish off with a Desmos activity. So make sure you do pause when I say pause, and then go off and try the activity and come back to this video. So if you notice in the post, there is a worksheet with a bunch of different information on it. So the first page of that worksheet is this, and then we'll get to the other pages in a second. So what I'd like you to do is look at this, and you could pause the video and just look at it here. You don't actually have to go to the worksheet. But what your goal is to try and match up all of these sentences with all of these graphs. Okay? You don't have to print anything out. You can just try and make the match, maybe write down the matches on a scrap piece of paper so that you can go and submit these answers to me. Okay? But I just want to explain what's happening. So your goal then is to take this sentence and match with one of those. You'll notice that the independent variable for all of these is time. So all of the scenarios are time. But the dependent variable is blank because the dependent variable is going to depend in the question. So the first question here says, we rode the roller coaster steadily to the top. Then we went faster and faster as we went down the other side. The speed of the roller coaster is the dependent variable. That is the variable on the vertical axis. So you're going to look at these graphs as if all of them say speed, okay? I didn't put speed on ones and then all the other ones, didn't label them all because then it'd be really easy to match up. But you're going to imagine that they all have speed on there. And then you're going to read this again. We rode the roller coaster steadily to the top, then went faster and faster as we went down the other side. And speed is the dependent variable. Okay, so you're going to go and look at these and make a pick of what graph it is. Okay, maybe you think it's E, so you might write that down. Okay, and then you're going to go on to number 2. The bag of popcorn heats in the microwave before the kernels pop. The kernels start to pop and continuously pop until they're almost all gone. The amount of unpopped kernels in the dependent variable is the dependent variable. So this time you're going to go off and say, okay, I don't want speed anymore. And we're going to come back and imagine that unpopped kernels is the new independent or dependent variable for all these. And then you're going to go off and pick. Okay, so you don't have to have these. You just imagine these variables in your head and then make your match. Okay, maybe you think this one's B. Okay, there's only one graph for every one sentence up here. So you're going to make your match. Okay, so that's the goal, and you can just do it off on the piece of paper. But what I'm going to do is, instead of you just coming back to this, I want you to pause the video and go to the quiz and test this out. So the quiz is going to have 7 questions with these and all 7 of these graphs. So you simply need to go in and put in your answer into the quiz, and then you'll find out if you get it right. Here's the fun part. I've done this a number of times. We usually do it in class, and rarely does anybody get 7 out of 7. So I'm going to challenge you to really think about these and see if you can get 7 out of 7. If you don't, I want you to learn from that and go back into the quiz and do it again. And I want you to complete that quiz until, keep doing it until you get 7 out of 7. I want everybody to get 7 out of 7 on this quiz. You're going to be really surprised at some of the matches. So do it as many times as you need to. All you have to do is push, after you push submit and check out your score, you can close the score screen and go back and say submit another answer. Then go and try it again. Try it again, try it again. Learn from your mistakes and see if you can get 7 out of 7. Once you get 7 out of 7, come back to this video and I'll show you why the answer is what they are. Okay, so pause the video, go to the quiz, keep doing the quiz until you get 7 out of 7, then come back here and I'll explain why those matches are they are. Good luck. Okay, so hopefully you have all tried it, and I wonder if anyone got 7 out of 7 on the first try. I'll be really surprised if someone does. Good job on you. Okay, maybe it took you a couple of times to figure out, and some of them you might still not understand why they are the way they are. So that's what I'm going to do here, is explain those. All right, so here's the chart. Let's look at that first one. So remember, speed, we're going to pretend speed is the independent or the dependent variable for all these. We rode the roller coaster steadily to the top, then went faster and faster down the other side. the speed of the roller coaster. I bet a whole bunch of people picked C for that one. And the reason people do that is because they say it looks like a roller coaster. But what's important is this graph is describing speed. It's not describing the shape or the ride of the roller coaster. It's describing speed. So this graph here would suggest that there's very little speed and it speeds up and then slows down. And that's not what's happening in this. It says that the speed is steady when it gets to the top and then goes faster and faster. So if it gets faster and faster, then the speed graph must be getting higher. So it can't be this. This would be something that's slowing down. You see how the speed gets slower. This is one that goes along and then slows down. It can't be these, can't be these. Okay, it might be one of these. This is speeding up. This is really weird. The speed is going up and down, up and down, up and down. Okay, this one is the speed is getting up, and then there's this one here. So it all has to do with the first sentence. The speed of the roller coaster was steady. That means it stayed the same. The speed stayed the same. So it's this one is what we're talking about here. The speed stays the same, and then when the roller coaster goes down, the speed goes up. And so it turns out that this is the first graph, and that is our first example. So that one we don't need to worry about. Okay, and that's usually the one that people get tripped up on. All right, let's go and check out the rest. The bag of popcorn heats up in the microwave until the kernels pop. The kernels start to pop and they continuously pop until all of them are gone. The amount of unpopped popcorn. Okay, so we don't need this anymore, so I'm going to delete this and we'll bring in the new one for unpopped kernels. So it says it's going to sit there and then the unpopped kernels. So that means when the popcorn starts to pop, the amount of unpopped popcorn must get lower. So this would suggest that unpopped popcorn kernels, the kernels got bigger. That's not the case. It has to go down. So to me, it's either this one or this one. So they go, this one would have the amount of unpopped popcorn go down. The amount of popcorn goes up, but the amount of unpopped kernels goes down. So it's either this one or this one. All the other ones go up. So it has to do with the beginning. It heats up before the kernels pop. So that means there's a time when nothing's happening. We all know this when you put the bag of popcorn in the microwave. It sits there doing nothing. And so the amount of unpopped kernels stays the same, which means to me, this is G. It stays the same. And then when the popcorn starts to pop, the amount of kernels gets smaller. And then notice the graph doesn't actually touch here because we all know that in the bottom of that bag, there's always a whole bunch of kernels still there. If it went down to the bottom, that would suggest there's no kernels left. Okay, and so because of that, number 2 is G. So we'll cross that off. Okay, now we don't need these anymore. I think we're fine for the other ones. The balloon was blown up in the class and let go. It flew around the room. The amount of air in the balloon is the dependent variable. So I see a lot of students tell me and their guess that it's E because they picture the balloon getting filled up and then flying around the room. Well, that's not what's happening in E. If we're talking about the amount of air, it does increase, which is good, but this would suggest that air is going out and coming back in, going out, coming back in, going out, coming back in, and that's not what happens. And it also would suggest that there's a lot of air in the balloon at the end. So it can't be E. Could be something else. Can't be this one. This would suggest the balloon gets filled with air and then sits there, and that's not what happens. We let it go. Can't be D because this would suggest air is getting smaller. Could be this one. It's getting up, but again, the balloon is left with a lot of air in it. So that means that C is our answer. It gets filled up, and then when it lets go, the air gets smaller. The amount of air in the balloon gets smaller. And again, notice that it doesn't go to the bottom because we know that after this happened, that balloon is sitting there and it's still got a little bit of air on it. If it had gone to the bottom, there would suggest no air. It starts with no air, fills up, and then comes back to something like this. And so that means that number 3 is C. And we've got that off our list. I think you're probably getting the hang of it, and why it gets a little bit tricky to get all these right the first time. At the beginning of the spring, the grass grew slowly, and I seldom had to mow the lawn. By the midsummer, it grew so fast that I had to cut it twice a week, and in the fall, I only mowed it once in a while. The number of lawn mowings to date is the dependent variable. So what happens here is it's keeping track of the number of lawn mowings to date, which means the graph has to always go up. It's counting how many times you mow the lawn. Okay. So again, you can't be this because that would suggest you stopped mowing the lawn or you took away one of your counts. If you're counting how many times you do it, I did it once, twice, 3, 4, 5, it's going to speed it. It's always going to go up. And if you stop mowing the lawn, it's going to stay up here. Okay. So it can't be D because that would suggest that your lawn mowing went down. And that isn't it. Some people guess E because it looks like grass. It's not. Again, that would suggest that you took off one of your tallies and then added it back on and took off one and tallied it, and then you just kept having, if this was 5 times you mowed the lawn and went down to 4, up to 5, down to 4, up to 5, no, it can't be that. So it's either B or F. B is possibility, but this would suggest that you're sort of counting and then it speeds up and you're counting a lot. Whereas F, it's kind of slow at first and then you count a lot, so it counts up. So it might go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then stop at 10. Okay, and that's kind of what's happening here. You do it a few times in the spring, a lot in the summer, and not so much in the fall. And so why number 4 is F. All right, number 5, I turned the oven on. When it was hot, I put in the cake. The cake baked for about 30 minutes. I turned off the oven and took out the cake. The oven temperature is a dependent variable. Okay, so we have to have something about the temperature. Obviously, when you turn it on, it's going to go up. The temperature is going to get warmer. So it can't be D. It's either going to be B or E. That's all we have left. This one suggests that the temperature goes all the way up and then stays there. And that's a pretty good guess. But let's talk about E. E suggests that it warms up to a temperature and then it cools down and warms up, cools down, 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 warms up. And in fact, if you actually paid attention to how an oven works, this is exactly what an oven does. An oven turns on to a certain temperature, let's say 400 degrees Fahrenheit. It stays there, and then it cools down a little bit, and then the oven kicks back in and warms it up to about 400, and then cools down a little, and then warms it up. And it's this continuous dance trying to stay around 400 degrees Fahrenheit. So it actually turns off and on as it cools for a second, warms it back up, cools, warms up. That way the temperature stays about the same throughout the whole time. So that means that this is E. Number 5 is E. The other way I like to think about it is if this is me cooking the cake, it warms up, and then you sit there and someone who really wants to eat the cake would open the door and it would cool down and then close the door. Is it done? Nope, it's not done. Open it done? No, done. Every time you open the door, you lose a little bit of heat. That's someone just staring on the cake, waiting for it to be done. And at the end here, of course, it takes a long time for the oven to cool down. It heats up a lot faster than it cools down. So that's why number 5 is E. All right, that leaves us with 6 and 7. Let's do 6. We bought a pair of rabbits last year. They had several litters. That means babies. And we have so many that the pens are full. If any more are born, we're going to have to give some away. All right, well, here all we have to do is decide B and D. And obviously it's B because it's having the number of rabbits is increasing. This would suggest the number of rabbits is going down, and it can't be that. So it's B. And the more rabbits there are, the more babies there's going to be. So that's why it curls up and speeds up. So B's off the list, which means D must be number 7. But let's just verify. I put the water in the ice cube tray, placed it in the freezer. The temperature of the water in the ice cube tray is a dependent variable. So if the temperature of the water, when you put it in the freezer, that temperature is going to go down to the fact that it cools down to 0 degrees and stays at 0 degrees because it's frozen. And actually, when you put it into the freezer, it actually cools down quickly at first and then sort of goes down to the 0 degrees. And so number 7 is D. All right, so there's that first worksheet. It's always a fun worksheet to talk about because often we get surprised of what these graphs do. And that's what today's all about, is trying to grab our head around the relationship between these data and understanding it. Okay, so what's going to come up next is the second part of the worksheet. If you were looking at it, it has this on the top half, sketch a graph, and this at the bottom where you're doing graphical stories. So first, let's go back and look at this one. I'd like you to try this on your own. So you're going to pause the graph or the video in a second, and you're going to try this. Now, obviously, you don't have to make this fancy. You don't have to print out this worksheet. You can just, on a scrap piece of paper, draw these axes, read the description, and draw what you think the graph will do. So here you turn on the hot water faucet. The temperature of the water runs depending on the number of seconds you turn it on. So I think it's safe to say the water temperature is going to be maybe start around here, because it's not going to start at 0. That would be frozen. It's going to start here, and then it's going to warm up. So you can draw a sketch of what you think it's going to look like. And then you'll come back and try and see my answers and compare. The second half of that worksheet is this challenge. So how this works is you're going to try and match up these sentences with these graphs. What I'm telling you is that only 2 of the sentences match 2 of the graphs. So there's 3 sentences here. Only 2 have a match. That means a third one does not have a match. Okay? So you're going to find the 2 matches, and then you'll be left over with 1 sentence without a match and 2 graphs without a match. For the 2 graphs that don't have a match, I want you to write a little sentence about those. So maybe you find A and C are the ones that match. So B will require a little sentence describing what it is. I'm not saying it's B. I don't know which ones it is. Okay, and then there's going to be another one that's left over. So you'll have to write 2 sentences for the leftover graphs, and there'll be 1 sentence without a match. For that 1 sentence, I just want you to do a little sketch of what that graph might look like. All of these are describing someone walking from their locker and going to class. Okay, so the time is the independent variable, distance from locker is the dependent variable, and you see all of the graphs are going up because as you go to class, you are getting further away from your locker. Okay, all right, so those 2 challenges. So what I'd like you to do now is pause the video. And again, if you want to look at the attached worksheet, you can, or you can just rewind a little bit and look at these 2 graphs, or maybe leave it on this screen and try these just on scrap piece of paper. You're not handing anything in, and then come back and for an explanation. So pause now and come back in a second. All right, so let's see how you did. The first thing I'm going to say is your sketches and my sketches, both of them might be right, but they might look a little bit different. And that's because there's no scale on these, okay? You might decide the water starts one way and I might start that it starts another place. We both might be right, okay? So let's try the first one. You turn on a hot water faucet. The temperature of the running water depends on the number of seconds since you turned it on. So a lot of people might think that it just goes up like this. So you start and you have it going up like that. And that, I think, would be an acceptable answer. Again, don't start it at 0 because that would suggest the water's frozen when it comes out of the tap. I would say it starts something like that and goes up, right? It continuously gets warmer and so forth. But I don't know about you, but in my house, when I turn on the water, it doesn't start to get warm for a little bit. It's sort of cold for a second, and then it takes some time for that hot water to get from the big hot water tank in my basement all the way up to the faucet. So there's a time where it stays the same, and then it gets warmer pretty quickly, and then it can only get a certain temperature. If you had this graph, that might suggest it keeps getting hotter and hotter and hotter and hotter, and that would be a little bit unrealistic. So instead of this graph, I'm going to suggest that the graph looks something like this. So It takes a second to warm up. It feels like it's the same temperature. And then once it starts to warm up, it warms up pretty quickly because that hot water has finally reached the tap from all the way in the basement. And then there's a point where it stays the same because it stays that same temperature. Okay, so I'm not saying if you drew this, I'm not saying you're wrong. I'm just saying I think this might be a more realistic graph of what might actually happen. Okay, and again, you might have drawn a graph that looks, something like this. You might have drawn it starting up here and going up like that. Okay, and that would be right as well because there's no scale on this. These are all possibilities. All right, let's talk about number 2. As you play with the yo-yo's distance from the floor depends on the number of seconds that have passed since you started. So the distance from the floor depends on the number of seconds. So when you start a yo-yo, it's in your hand and it's above the floor. So I think it's going to start up here. And then it's going to go down and it doesn't quite touch the floor. And then it's going to hopefully come back up to your hand and down and hand. And so I would suggest the graph looks something like this. Okay, it should come up to about the same place it starts as you're doing the yo-yo. Now, you could also do this graph, because if I was doing this graph, I might do this. I have the axes like this, and I might say, when I do a yo-yo, it does this. Because I'm not very good at a yo-yo, and I just try it, and it never comes back up. It just hits the floor and then stays down there. So this might be my graph because I'm not very good at a yo-yo, but someone who knows what they're doing would come down and then back up and down and back up and down and back up. All right, next, you go from the sunlight into a dark room. The diameter of your pupils depends on the length of time you've been in the room. Okay, so a little bit of science going on here. So for this, when you're outside in the sunlight, your pupils, that's the black part of your eye, gets actually really, really small. Because of it's so bright outside, your pupils get small and they don't want to let in too much light. Okay? And then when you go into a dark room, it feels like it's pitch black. And that's because your pupils are so small and you're not getting enough light. So what your pupils do when you get into a dark room is they get bigger and bigger and bigger because they're trying to let as much light in as possible. And I know you've all experienced this. If you've been in a room and the light goes out, it feels pitch black. But if you wait a couple of seconds, you can start to see a little bit. Not great, but you can see a little bit. That's your pupils dilating and getting bigger and bigger and bigger. So I would suggest that the graph looks something like this. It starts, your pupils get really small, and then as soon as you walk into that room, your eyes make a big adjustment, and then they get up to a new size, and then they stay that size, and they're really open, trying to get as much light. And then, what the opposite happens, if you're in a dark room and your eyes are really dilated, how someone turns on the light really quickly and it hurts? That's because your eyes are wide open and they're trying to get as much light in there as possible. And then all of a sudden when the light comes on, you're getting a whole bunch of light and your eye immediately closes and tries to get smaller. That's why it hurts. Okay, next, you pour some cold water from the fridge into a glass and leave it on the counter. The temperature of the water depends on how long it sits there. Okay, so if you're pouring cold water from the fridge, the temperature is going to start pretty low. I don't think it's going to start at 0. Again, that would suggest that it's frozen. Okay, but when you leave it on the counter, the temperature is going to warm up. Now, is it going to keep warming up? Is it going to be like this? Is it going to go like that? Well, no. If it's just sitting on the counter, it can't keep getting warmer and warmer. It is going to warm up a little bit, but then at some point, it's going to stop. So I'm going to suggest I do something like this until it hits this temperature, and it's going to stay that temperature. That temperature is called room temperature. It's when any object in the room sort of all feels the same temperature. So the water is going to go up and reach a certain temperature, the same temperature of the room, and then stay there. Okay, so there's an idea of some of the sketches that you can do for these scenarios. And hopefully your sketches were similar to this. I'm not saying they have to be exactly the same. All right, let's go on to the last one. Graphical stories. So I explained what was going on there. Let's first look at the first scenario. So I left my locker, started walking to class, but I realized I'd forgotten my notebook. So I came back to my locker and then went quickly to class. So hopefully we discovered that only one of these actually has the person coming back to their locker. So if you start on your locker and you go along, this suggests you just keep getting further away from your locker. So this one doesn't come back. This one doesn't come back. This one goes and then stops, but then keeps getting further away. So I think C makes sense. You was walking and then realize you forgot something, so you come back. So your distance from your locker comes back to 0. Maybe you got 10 meters away, but then you come back to 0 meters because you're back at your locker, and then you realize you better go quickly to class because you don't want to be late, so you race off to class. So that means this one is C. So we can take that off. We don't need it. Next, I was rushing to class when I realized I wasn't late, so I slowed down. Okay, this one, you're going along at the same speed the whole time, constant speed. Your distance increases at the same rate. So we need one that slows down. So slowing down, which would mean that you didn't cover as much distance. This graph, I'm going to suggest you start slow and then go fast. Whereas this one is you start at a certain speed and then slow down. Okay, so the distance you cover is not as much in the second half of this graph. So that means that this one is graph D. All right, so we've already found the 2 matches. That means the third one doesn't have a match, and these 2 need stories. So let's talk about this. I was walking to class and realized I was late, so I ran the rest of the way. So that could be this, but I think this story here actually has someone stop. So for B, I would say I was walking to class. Maybe I saw a friend, so I stopped. Distance didn't change. And then I realized I was late. So it's not quite this. This says I was walking and then realized I was late and went straight to class. So I think this sentence here is something like this. B, I walked, stopped, then ran to class. The key is that they stopped at a friend's locker or something. What would number 3 look like? Well, to me, I think it would look something like this. You were walking and then you realized I better hurry up and then immediately sped up. So that's what the graph for number 3 would look like. Okay, so we've done all those, and now that just leaves this one. And this one, we just walked straight to class at a constant rate. Okay, the distance remained it kept increasing at the same rate, which means you're walking at the identical speed the whole time. And that's done. Okay, all right, so hopefully you enjoyed those 2 or those latest 2 activities. What we're going to finish off with today, a Desmos activity. But what you're going to do is go to student.desmos.com, put in that code, and you're going to get to this activity. So this is similar to the walkout thing of the guy leaving the building, where you're going to watch a video, but this one's going to ask you to draw some sketches of what you think it's going to look like, and then you'll test it. So in this case, we're going to watch the video, so we can watch it quickly together. You'll do this again when you get to the Desmos activity. So the guy's up on the slide, sits down, and then slows it down here. All right, so the question says, what different measurements are changing in this video? I don't need you to write out a lot of stuff here, so you might not even do anything. I'm going to just say, hey, how high above the ground. Oh, okay, that's one thing that's measuring. There's lots of things that could be measured, but don't spend a lot of time here sharing that information. What I'd rather you do is go to the next slide, because the next slide gets you to draw what you think this graph. Now, it's important you read the axes here. In this case, it says the height of his waist above the ground. Okay, so his waist is right here. And as he climbs, I think it's going to go up. So maybe his waist is about here. Now, you see, you're going to actually draw here. So you can draw like this. Okay, I'm just going to erase that. So you can just use a freehand pencil like is there, or if you want an actual line, you click the second tab and then you get straight lines. Okay, So I don't care which you use. It's up to you. You can either use the pencil or the line tool. That's the erase tool. Okay, but you're going to draw a sketch of the graph. So I'm not going to give it away from you, but it's obviously going to start by going up. Okay, after you draw a sketch, what you get is your sketch here, and then you get to watch the video. I'm just going to start it. Okay, look at that. Okay, now you're getting an idea of what the video is going to look like, and then you'll be able to compare your sketch with the real sketch. Okay, and it's just fun to try and predict what the graph is going to look like. So you're going to do a sketch, watch a video, and then see how you did. Okay, and then you move on to the next one, next scenario, draw your sketch, and see how you did. Okay. All right. Oh, by the way, when you get to the very last one, it talks about a challenge. You're welcome to do your own challenge with it, but you don't have to.